Hello, I am Jackson Leffler, and this is my presentation on future transportation and the use of electricity and magnetism. First and foremost, why? Why are we looking for alternatives? Why are we straying away from fossil fuels and proven energy transportation methods? This could be for a number of reasons. It could be out of necessity, it could be in a time of war, or it could just be to enhance the lives of so many. In this case specifically, many companies are seeking out electricity and magnetism as forms of propulsion and transportation for the future, as they offer less emissions than fossil fuels and offer a cleaner environment for the future. While this has been on the rise for a while, many companies now are taking large steps to offer alternatives for fossil fuel propulsion methods in transportation today. While Tesla and Hyperloop One are at the forefront of this, many smaller companies are taking action to produce other alternatives, such as electric-powered airplanes and solar-powered cars. But with so much going on, it is easy to ask, when will we see these alternatives come into play in our society? Well, with these projects taking so long to develop, we cannot expect to see change today or tomorrow, but in the coming years, we can expect to see alternatives with electricity and magnetism in our transportation. In my presentation, I would like to give 3 examples of how this technology is being used today and in the future. The first example I would like to bring up is Hyperloop One. Well, what is Hyperloop One? Hyperloop One is a new transportation system theorized by inventor Elon Musk. Its goal is to transport people around the world at very high speeds, very efficiently, through the combination of many types of technology. It will do this by placing an electric motor on a pod on magnetic levitation technology tracks within a near vacuum tube to reduce friction and increase speed. With so much technology and innovation going into this project, it is scheduled to be completed by 2021. As pertaining to electricity, Hyperloop One does include an electric motor as a main form of propulsion within its system. While this is the case, Hyperloop's electric motor is somewhat uncharacteristic compared to others. In a conventional electric motor, there are 2 parts, a rotor and a stator. The stator is typically an electromagnet with a current running through it which causes the rotor to spin and moving forward whatever is attached. While in the case of Hyperloop One, the parts of the electric motor are the same, but the layout is different. In this case, the stator is placed on the track, while the rotor is placed on the pod levitating above the track. This causes the pod to continuously be moving forward. While this technology is new, it can be seen in other applications, such as railguns that are currently being tested by the Navy and Army. As far as magnetism is concerned, Hyperloop One does intend to use magnetic levitation technology within its system. Magnetic levitation technology is where an electromagnet will be placed on a pod with a naturally occurring magnetic material placed on the track. This will cause either magnet to repel each other, suspending the pod above the track. Hyperloop One intends to use this technology to guide their pod along the rail while also reducing the friction of the pod touching the rail. While this technology is fascinating, it is not new. Many countries around the world have implemented magnetic levitation transportation, such as trains, as part of their public transportation systems. While moving on from Hyperloop, we will look at a smaller scale project that also intends to have great benefits within the transportation of the future. The second project we will look at is electric airplanes. While electric airplanes are still airplanes, they do differ from conventional planes in a number of ways. For example, electric planes are much slower than conventional planes and obviously do not use gasoline or jet fuel. With this, some may ask, why create electric airplanes? What use do they have for us today? Well, Simon's Vice President Terry Hamlin had this to say on reasons for why electric airplanes should be developed and used in the future. 1, it reduces our use of fossil fuels. 2, it will reduce emissions produced by fossil fuels that hurt our environment today. Finally, there is a large problem with noise from conventional aircraft today that electric airplanes will take care of in the future, as electric motors are virtually silent. While this technology is very new, many people suspect that electric airplanes will be common in the aviation industry by the year 2050. With electric airplanes being so new, it can be easy for many people to ask, how do they work? Well, an electric airplane works very similarly to an electric car of today. This is where the engine in the vehicle is replaced by a standard electric motor. As stated, a conventional electric motor has two parts, a stator and a rotor. With the stator being an electromagnet, it needs a power source. This power source is typically a battery or batteries placed throughout the vehicle. This is where the problems arise for the model of an electric airplane. This is because to store enough power, there will need to be an excessive amount of batteries on board of the airplane, causing it to be too heavy to fly. To combat this, companies like Simon have taken great measures to solve this problem. One potential solution is to rely more on gliding and aerodynamics within the plane to keep it in the air longer, without using more energy. Secondly, they are working on power density within the battery while also trying to reduce the weight of the battery to store more power and keep less weight on board of the aircraft. While electric airplanes are not here today, we can expect to see them soon. This is compared to other forms of transportation, such as solar-powered cars, which are still in the infancy of being developed for optimization and commercial use. While solar-powered cars have not been around long, they have been an idea of many since solar power has been optimized to be used for a greater source of energy. Today, solar-powered cars are typically used in forms of competition. For example, some organizations will hold competitions between engineers to create a solar-powered car and race them against others who have done the same. So far, solar power has been used sparingly in commercial cars of today and cannot be expected anytime soon, as the technology is not optimal today. With solar-powered cars being so cutting edge, people may have the same questions they did about electric airplanes on how do they work. Well, a solar-powered car is very similar to an electric car. The engine is now a motor with a rotor and a stator. The difference comes in from the power source. Instead of a battery or batteries, the solar-powered car will get its energy from the sunlight and solar panels placed on the body of the car. But today, there are many problems with solar-powered cars. As I have previously stated, solar-powered cars are mostly used in competitions and racing today. This means these vehicles have been optimized for racing. This means that today, there are problems with both the body and solar power itself that have kept these cars off the road. With the body, these cars are very small, only fitting usually one person, as they are meant to be kept very lightweight and fast. The body is also optimized for aerodynamics, leaving little to no space for storage within the car. Finally, since the car is optimized for solar power, the surface area of the car is much larger than a normal car to place more solar panels on it, therefore gathering more energy. The other problems come with solar power itself. Solar power today is not very efficient and does not produce very much energy compared to other methods. This means if not optimized for racing such as these other cars, solar power will not produce enough energy to move a conventionally designed car of today. Solutions can come only from the optimization of solar powers and solar panels so that they produce enough energy to move a car. While these are only 3 examples of how electricity and magnetism can be used in transportation of the future, there are many other projects being worked on to better our society for today and the future. For example, today we have electric cars that will need to be optimized to go further and have a longer range and be able to charge faster to be more commercially used. Another example can be solar-powered planes, which will use solar technology and gliding aerodynamics to keep the plane in the air. A third example is magnetic levitation trains. Today these trains are used in certain countries around the world, but can expected to be moved into every country and connect our world. Finally, we all remember when Lexus used magnetic levitation technology to create the hoverboard of the future. In conclusion, we are innovating our transportation of today, moving towards magnetism and electricity as they will benefit our future while reducing emissions and creating a cleaner environment for all, with the only downfall being the more electricity-powered things we produce, the more electricity we will need, and doing that in a clean manner is imperative. This is all I have for you today. On the next slide, you may see the references I used for this PowerPoint. Thank you.